understanding what sort of analytics are required for real-time data analytics as opposed to the batch processing systems. Okay, let's have a quick look into that, guys. So real-time big data analytics. So when I say real-time big data analytics, social networking. For instance, if I consider social networking as one of the end users of, say, real-time big data analytics. Let's try to understand what all kind of real-time analytics are possible with social networking. So pick your own database, big database like RDBMS or NoSQL. So you will pick one of these databases like RDBMS or NoSQL. Measure the immediate impact to your site traffic from social media. Okay, so through social media, you will first try to understand the immediate impact to your application, whether a new blog post, a tweet, a like, or even a comment. I'll talk about the use cases in detail. Let me finish this content first. And then knowing this information translates to better conversion and more effective online campaigns. Guys, let me take more relevant use cases rather than conceptually how the use cases can be built or how it could result in benefits. Let me take few examples. Let's consider airports. That's one of the example, guys. So the major concern for airports is to actually optimize the operations within the airport. Why do somebody want to optimize the operations within the airport? Because see, one of the key problems of airlines is they wanted to keep flight on air. No airline would like to keep flight on ground, because if the flight is on ground, it's not generating any revenue for you unless the flight is on air. So that's one of the key problem for airlines. And if you consider airports in this case, see, they have to actually optimize the entire operations, so through which they can provide no delays, or they actually come up with more optimized operations for airlines. So at a high level, if you look at airports operations, it could be contract and billing. I mean, see, for each airline, there could be some third-party vendor who actually manages all the flight-related stuff, like handling the food, drinks, all this stuff. Will be some third-party vendor will be handling for all the different flights. So this is called as like contract and billing. And there could be some other stuff like say flight sequencing itself, like sequencing of flights for takeoff or for for landing. Okay, and then as somebody already referred, that baggage handling or traffic management. So these are various operations being performed within the airport itself. To optimize this, there need to be a real-time system getting events generated from different sources. One is through baggage handling, one is through traffic, one is through sequencing, one is through the contract and billing. So these are different sources where we need to actually handle the events. So why do you need to handle the events from all these different sources? Because these are interrelated to each other. Okay. So why are this? I mean, what would happen if one goes down? Then automatically that will affect in the entire delay of the flight. So delay in the flight, which means that cost to the airline. So in order to reduce the costs, or in order to provide the optimized service to the airlines, I mean service to the customers, and reduce the costs, you need to actually analyze what's happening in the real time, and you try to provide better solutions in the real time by analyzing the data generated from all these multiple sources in real time, folks. So this is like one of the interesting use cases, in fact, which has been kind of yet to implement kind of thing for airports. And then there are a few other use cases also if you consider networking or security. Networking, if you consider, So you have to handle data, I mean network traffic generated from different network analytics and network elements, and then try to analyze all the network flows in real time. Say for instance, if you are coming up with some intrusion detection system or intrusion prevention system, so you have to monitor the network flows in your network very closely in real time. Then only you can be able to handle the intrusions within your network, and that has to happen over the real time, folks, because delay in handling the intrusions will result in bringing down your entire network, which will again result in huge loss of money over there. Okay, so it's like that. So there could be few other use cases, like for banking. Probably they wanted to understand, how the customers behave over the application in real time. Or for e-commerce, so e-commerce, they have to, on demand, they have to come up with offers for the end users to have better conversion rates based upon the user's behavior. So again, that also, if you see sometimes, if you open up some website, and if you open up any e-commerce application and try to access one product, after some time you'll get better and better offers. If you could have noticed it, especially I personally noticed it with Snapdeal application. Basically, if you just try to open it and just keep it on for some time, it's not always true again. Don't do that. Sometimes you will get on-demand offers after like 1 minute or 2 minutes. You'll get some more and more offers. It's because there is like huge competition over the e-commerce markets. So people are very smart that they actually compare against all the different e-commerce sites which are providing the service, because pretty much everyone is providing genuine service. So they'll actually try to compare the prices, or they might compare some services offered by different e-commerce sites. Based on that, they'll actually go with the conversion. I mean, they'll go and complete the transaction. So that's how companies, I mean, these kind of products has to do real-time analytics. So that can be possible by that can be possible, and like knowing this information translates to, so what is the benefit out of it? So if you try to analyze the status set over real time, will yield better conversion rates and more effective online campaigns, guys. So real-time big data analytics continued. So SaaS is one of the service which actually offers real-time data analytics as well. So measuring user behavior and acting upon it is crucial for improving the customer satisfaction and conversion rates for the customers, and which represents immediate increase in revenues. So why somebody has to worry in conversion rates? So conversion rates basically either yield more revenues, or maybe they'll either yield better user satisfaction over the application, folks. Okay, so real-time big data analytics again. So in financial services, if you look at the importance of real-time analytics, real-time big data analytics, so determining in real time whether your portfolio is losing money or if there is any fraud in your system. So basically, in order to analyze your portfolio properly, so there is need of real-time big data analytics, because you have to analyze the data from multiple sources, and it is vast in use in nature, especially for banking, banks, and other finance entities, and can prevent disasters as they occur, not after the damage is done. So in order to identify the disasters and before the actual damage happens, so it's necessary to analyze the data in real time, folks. And correlating multiple sources from the market in real time results in more accurate view of the market and enables more accurate actions to maximize your profit. So it's always, it's crucial to understand data generated from multiple markets, multiple sources from the market in real time, or even multiple markets also. And more accurate view of the market will enable more accurate actions to be taken in real time. Okay. So guys, now the time has come for us to look at, now we are at the, we are at a section where we actually look at some basics of Storm and some other competitive products in the market. So folks, if you look at this slide, so you guys can find that real-time big data analytics are possible with three different, I just have listed only three different options over here. But however, there are multiple other options also for doing real-time data analytics, data processing. Okay, so among which the most interesting ones are Amazon Kinesis is one of the interesting real-time data processing, data analytics system, big data analytics system. Samza is again Apache's project only, Samza, and then finally Apache Storm. Okay, so the key difference between the rest of this frameworks or the rest of these tools like Amazon Kinesis, even though all these three are actually meant for processing big data in real time, but the key difference and the key differentiator against Storm and the rest of the tools are actually, it is at least guaranteed that any given record, okay, is processed at least one time in the Storm cluster, folks. The minimum guarantee Storm will actually offer is any record, every record will be processed at least one time in Storm cluster. So that's the key differentiator as opposed to the remaining two frameworks which I have listed here. So that's how, and in fact Storm is becoming more and more popular. So basically Storm initially has been developed by Twitter and then open source through Apache. Who's the author of Storm, folks? Storm is relatively a very small framework. I would say like it has like closely around some 10 to 11,000 coding lines, okay, which actually offers a parallel processing system, parallel processing real-time system for the data, for the large data sets. So I think Paul says it's Nathan Marsh, correct. So Nathan Marsh is the author for Storm, folks. Author, I would say, rather than author, I would say maybe kind of founder for Storm, right? Instead of author. Okay. Okay, so now let's, I mean, other than this, there are few other tools also which does the processing in real time, other than Samza, Amazon, and Storm. You have, however, Spark. Spark is a different story altogether. It does the data processing in real time, in memory, and it does in memory analytics. And you have the frameworks like, say, Esper. Esper is a package which I have used for one of my R projects. So I was actually running some learning techniques over R. So there actually I had a necessity to actually feed the real-time data set into R. So there I used Esper package to actually pass the data into R. However, Esper is not a scalable system. It's just a standalone system, but it does the streaming data processing. And you can actually supply the data from Esper package to R also. So that within the R I can build, I can run whatever the necessary algorithms. Okay, so guys, a need for real-time analytics. Let's try to understand what is the base need for running real-time analytics, guys. Okay, so if I just have considered as very simple example in today's session, which is I just have taken Edureka's problem statement itself. Okay, so here I am just trying to understand some simple statistics, guys, based on my website, based on Edureka's website. Okay, so in order for me to understand the user's traction over the Edureka's portal, I mean, what all the courses users are interested in, okay, what all the courses customers are interested in. So I would like to actually understand the number of hits over each page in the application. So in order to come up with such real-time analytics, so I can just build, in the right side you guys can see that for each page, so say Apache Storm, there are 882 views, which is like in the total number of hits it is almost around 5.81%. So data science is, you can see 789, and beginner's guide for Android it's like 645. So this is how I could actually determine, the traction of the users through the simple statistical analytics. But in order to come up with this kind of reports, I have to actually do this in real time. Okay, of course, if you look at some third-party, services, for example, Google Analytics is one of such services, right? You can actually integrate Google Analytics with your application. So let the Google Analytics will does everything on behalf of you. It will monitor your application closely, and whenever there is a change or events getting generated, what Google Analytics do is it will capture the data in the backend, and it will actually generate all this kind of all this kind of static reports for you. Okay, so through which you guys can analyze how the users are navigating and what are the interests of the users over your application, folks. So this can be used either to improve your application interface itself, or else probably to understand what users are really interested in, so that you can come up with better advertisements or better targeted ads to the end users, folks. So the problem statement here is to find the total number of page views of Edureka's blog over a range of time. So for a given period, I would like to understand the page views on all the different blogs in Edureka. And then Google Analytics can provide you this information, but for a particular day, the data can be like this. Okay. So guys, there is a need for real-time analytics solution for this kind of problem statements. Querying huge amount of historical data will be very slow. Okay, so querying for this over the massive data sets. So if you are collecting for say last 2 years, or say last 1 year, if you are collecting the data. So if you want to query this kind of information with on top of last 2 years, okay, so it will be very, very difficult, right, for me to query on last 2 years history. It will be very difficult because it has to go in a batch oriented mode, because there could be a lot of data generated every day, and the parallel computation has to happen over Hadoop stack. Even though Hadoop yields results in an efficient way, maybe like half an hour or 1 hour, but still it's a bottleneck for me to understand the data, to run such queries over the historical data. Rather than this, what I would do is, I would be rather more interested in looking at delta of the data delta. Okay, so when I say data delta, it is nothing but, if you look at the combination of both batch oriented system as well as the real-time system working together. Basically, batch oriented system is good at processing the historical information, and you process the past historical data through the batch oriented system, and you capture the data in real time, say past 1 hour or say past 1 day. Okay, and you differentiate that data with the historical data. So that will yield the better results, folks. So you can pre-compute the data over the batch analytics, and for the immediate data needs, like to understand what happened exactly in the last 1 hour, along with the pre-computed data generated from batch analytics, you can use the real-time stacks, real-time big data analytics solutions. Okay, so you have, that's called as, the difference between the data is called as data delta, folks. So all data petabyte scale, so it's very slow. When you try to, the moment you try to process the entire data at once, so it will be very slower. Okay, then pre-compute historical data. The solution for this is, you first pre-compute the historical data through batch processing system. So all data you have pre-computed view, and then you query the batch analytics system. and then need for real-time analytics. So for getting that latest information, I mean last 1 hour what has happened. If you look at this specific slide, it gives you a very intuitive information. Okay, so on real-time analytics, see. So these are different blocks, right? So on these different blocks, you can see for last hour of the day. So what happened in the last 1 hour, last 2 hours, last 3 hours, 4, 5. So you can see the page views over here. So this kind of real-time data processing also is possible using the real-time analytics. Even though you can process historical data through batch processing system for say last 1 year or so, but for the current state, you can actually use real-time analytics to generate this information, folks. And anyhow, however, this looks like, pre-computed view of the data, right? So where you do the pre-computation for every 1 hour using the batch analytics system also, and you query the data set, guys. So these are like different page views over here, and this information is been computed in batch mode every 1 hour and through a near real-time system, and then you query on that data set, and then you can combine it with real-time system to get the current state of the information. Okay, so the need for real-time analytics basically is driven from that description itself. So in the previous slide, if you see, we are actually pre-computing the data in a near real-time system through batch analytics mode, in the batch analytics mode, where you compute the data every 1 hour. So here, that can be achieved using Hadoop through pre-computed view. But at the same time, if you have to understand the current state of the application, then you need to plug in real-time analytics to your solution, to your system, folks. Okay. So before I take this slide, so I can see some question from Paul. Paul says, what we used batch analysis and combined it with real-time system. Okay, am I getting right? Correct, Paul. So far, I mean, what I am trying to convey over here is, see, all these 3 slides. I mean, I just introduced the problem statement over here to just identify the number of views, okay, per block. So considering this is crucial for few applications like say Edureka's application itself, or there could be some other blogging websites where they wanted to analyze this kind of information in real time. So processing massive data sets could be difficult. So that's where batch processing system comes into picture, and it does the data processing over the petabyte scale. It could be slow, but we actually generate the data and store the data somewhere in some HDFS or some NoSQL databases from the batch processing mode. Okay, so through which we can query the data up to that way. I mean, until when we have processed, up to that we can query the data. In this case, in the batch processing mode. So pretty much the same thing I am trying to explain you with an example. So hourly basis, if we are running the batch processing system, so it can generate the pre-computed view for every 1 hour. So even though you can query at hourly level data, I mean the last hour what has happened. At the same time, I mean through Hadoop it is possible, right? You can run your workflow every 1 hour and you can generate this information which I have shown it here through Hadoop system or Hadoop stack, and you can query the data from the last computed view. And since the data has been stored, that computed data has been stored either in MongoDB, any NoSQL flavor, or say HDFS also, it does not matter much. Okay, but what if I wanted to get the current state? What is the need for real-time analytics? Say if I wanted to get the current state, so how I could accomplish that? So, but what about the data generated after the pre-computed view? So after this pre-computed view, I mean like before say 45 minutes I have pre-computed using Hadoop stack. So what if I wanted to understand the data up to that point where the, up to now, exactly now. Then you need to actually plug in a real-time analytics solution, folks. Okay. So if you have a real-time system integrated with a batch processing system where you still leverage on the batch processing system for generating the near real-time or batch, a pre-computed view of the data, and you use the real-time data analytics solution to get that data delta. To get the data which has been generated in that in that current 1 hour. Okay. And you do the difference between your batch pre-computed view and you get this current state of the data. So you combine both and you can be able to solve your problem using both the systems. So where one is actually helping you to process the current data and one is helping you to process historical information. Few of data, the current state of the data. So for processing the real data, real-time data set, or processing the streaming data which is coming into your application, so you will now leverage on Storm, folks. Okay, Storm has the abstractions of two things mainly. One is Spout and the other one is Bolt. Okay, so these are two main components within this Storm. Okay, one is Spout and the other one is Bolt. Just try to grab these names. That should be pretty much sufficient for this slide. And then these spouts and bolts actually help us to process the data in real time and get the real-time view of the data. And you store that real-time data view into some databases, some NoSQL flavors like say Cassandra, HBase or RAC. So these are all NoSQL flavors, right? So you use any one of the bolt to persist the final, after the final processing, you persist the data into any one of these NoSQL flavors, guys. Okay. So let's try to understand. When I actually mentioned that Spout and Bolt both are actually part of Storm framework, let's try to understand a little more on these two components. So Spout or Bolt, so both are as simple as functions, guys. I would like to say that they are, you can actually consider either Spout or Bolt as the programs, or else as simple as a function which does certain piece of processing over the input data which you give it either to Spout or Bolt. Okay, it does some piece of computation over your data you have supplied to these programs, either Spout or Bolt. Spout will act like the source of data. Okay, so you can have one Spout which will be acting like a source of data, and you can have multiple bolts where you actually define the actual functionality, your actual business logic within the bolts, where you process the data. It could be anything. It could be joining the data, or it could be aggregating the data. Okay, it could be doing some processing. It could be any sort of computation you can define within these bolts. Or it could be interacting with NoSQL databases, or it could be interacting with RDBMSs. Anything you can actually define using bolts, folks. Okay, in the bolts. And Spout will act like a source of data. Again, when I say source of data, it's not really originating the data. Rather, it's just like primary way of communicating, primary way of ingesting the data into your cluster, into your Storm cluster. So Spouts basically has the capability to connect to the outside applications. In the sense, we have discussed so many applications so far, right? Like it could be say something like message queues or say message brokers like Kafka or RabbitMQ, these kind of message brokers. It can connect to those message queues, or it can connect to some third-party applications like Twitter through some APIs like Twitter 4J, and it can start capturing the data from those sources and do some cleansing activity over the spout, and then further pass the data to the further bowls which has been configured to it. Okay, and in the further bowls the data processing will happen, folks. So this is how the flow, I mean very layman flow as of now, okay, will happen in the Storm.